Again, welcome to lecture number 2. In this lecture, we are going to discuss about real numbers. Again, this is a pre-calculus class I'm teaching at New Jersey City University. And this is Mathematics 164. So again, this is my lecture 2 in this class. What is a real numbers? In this session, we use the set of real numbers as a universal set. And we can also represent the real numbers along line called a real number line. Normally, a real numbers will be a numbers, for example, 1, 2, 3, up to any amount of values. So this number line is a picture or a graph of the real numbers. And let's go straight to the next slide, what we mean by the line. So this is a real, we can say a natural number. A natural numbers will be 1, 2, 3, the counting numbers. So this is an example of what we mean by real numbers. Here we have 0, 1, 2, 3, 5, negative values included. These are natural numbers. Integer numbers are also natural numbers. So here we say a natural number is a counting numbers. And the integers, in computer science, integers are whole numbers like 1, 2, 3, 4. Then we have a float, which is a decimal number, 1.6 or any decimal number. But here, integer means the natural number 0 and the negatives of the natural numbers. So natural numbers, 1, 2, 3, counting numbers. Integers will include the negative values, 0, 1, 2, 3, negative 1, 2. Then rational numbers is what we are seeing here. It can be a fraction. So all numbers that can be written as a ratio of two integers, a by b, or 5 by 4, or negative 6 divided by 10. But b cannot be equal to 0. As we all know, any number divided by 0 does not exist. It's an error. So two integers values, a by b, we can say 0 divided by 10. Yeah, that's good. So any value, 0 divided by any values, the answer is 0. But any value divided by 0 does not exist. And irrational numbers, we can see example here, can be square root. So those are real numbers that cannot be written as a ratio of two integers. Irrational numbers have a decimal representation that neither terminate nor repeat. So square root of 2, square root of negative 3, etc. And then the real numbers will be 0, 1. So here we see a set containing all rational and also irrational numbers. The entire number lines. So 0, every number from negative 3 to 3. So we can see the difference. Natural numbers is counting. Integer can be negative and positive value, but natural numbers only positive. Rational numbers, we have fractions also. In rational numbers, we can have a square root, which means the decimal representation cannot be terminated or can be terminated. Like square root of 2 can be 1.4141414 throughout. So now let's go through the properties of real numbers. So here we say let A, B, and C donate a real number. So we are assuming A, B, C is a real number. This is a mathematics that we always study from elementary school. Property of a real number is commutative properties. Commutative properties for additions and multiplication. It's very simple. 1 plus 2 is the same as 2 plus 1. So A plus B equal to B plus A. Or A times B is the same as B times A. 10 times 6 is equal to 6 times 10. This is commutative properties way back to elementary school. Associative properties for addition and multiplication, we are changing the parenthesis value. So we have A plus B in parenthesis plus C is the same as A plus B plus C in parentheses. So we can see the reason why, because they are all additions. This also, they are all multiplications. For example, 2 times 3 is the same as 3 times 2. But 2 divided by 3 is not the same as 3 divided by 2. So that's why we are doing the associative properties for only addition and multiplication. We also have additive identity. Additive identity is 0, which means if I have a plus 0 is the same as 0 plus a, and the answer is a. Multiplicative identity is 1. Any number times 1 will give you the same number. Any number plus 0 will give you the same number. So that's the additive identity is 0. Adding 0 to any number will give you the same number. Multiply 1 by any number will give you the same number. And also each real number a has an additive inverse denoted by negative a, which means that if I have a plus negative a, so this means if it's 2, 2 plus negative 2 will give me 0. So a plus negative a is the same as negative a plus a, which will be 0. And here we should note the difference between the negative number and the negative of a number. So if I have, for example, negative 5, it's a negative 5. Now, if I have negative 5, it means negative times negative 5. So multiplicative inverse. Inverse means raised to the power a negative power. So it will be reciprocal. So this is the example here. A to the power negative 1 is 1 over a. A to the power negative 2 will be 2 over a. So a times a to the power negative 1 will be 1, because a to the power negative 1 is 1 over a. So we get a divided by a, which will give me 1. So multiplicative inverse of a non-zero real number, a, is 1 by a, which we call the reciprocal of a. So a to the power negative 1 is the reciprocal of a. Then distributive law for multiplicative over addition. Here we have a parenthesis b plus c. We are going to distribute a to both b and c. So we get a times b plus a times c. The next will be the inequalities and intervals. So inequalities, we use the relational operators. The symbol here written, the left arrow means less. So here we are saying that a is less than b. This is true statement. 4 is less than 7. Or 7 is greater than 4. Now, when we have less than with the dash, it means less than or equal. So here we say x is less than or equal to y. Here again, we go back. It's only left arrow. Left arrow means less. Right arrow means greater. When you have line underneath means equal. So here, if you have a is less than b, or 4 is less than 7, or 7 is, this is a right arrow now, 7 is greater than 4. Or we have s is less than or equal to 4, or p is greater than or equal to 4. Right arrow with underline means greater than or equal to 4. We also have an open interval. So here, what we mean by open interval is a value between a to b. So here we mean the values between a to b. So if I have x is greater than a but is less than b, which means s value is between a to b. Or we can say s is less than or equal to b and greater than or equal to a. This means it's between, this is called a closed interval. It's the actual, so if we have 2 here and 5 here, it means s is either greater than or equal to 2 or less than or equal to b. This is open interval, which means it cannot be 2, but it will be close to 2. It cannot be a, but close to a. Now we use the 2 symbols. Parenthesis, in my arrow here, this is the open interval symbol. and the square parenthesis, the close. So if I have open AB, it means, let's say X again, this means S is greater than A and less than or equal to B. Where we have the square parenthesis means equal. So this means X is greater than or equal to A and less than B. So parenthesis, regular parenthesis is open interval, and the square parenthesis is the close interval. So these are some of the examples. X is greater than A means from A to infinity is greater, so A to infinity. S is less than B means what? It's less, so negative infinity, the smallest value up to B, but close interval, we can see close interval. This means between A and B, close interval. And we use the graph symbol open. So when we have a dot with a O, it means it's open. We can see the close. A here means greater than or equal, so it's close, A is close, so we can see close, and the arrow go infinity. Now, if it's between, we can see here A close, dark point, point with a hole, which means it's open. So it's between A, this means if it's X, X greater than or equal to A or less than B. This means X greater than A or less than or equal to B. This means both close interval. So this means X is greater than or equal to A, less than or equal to B. And these are, again, the expression. So next we go to the absolute values. The only thing we should know is the absolute value is that any value, whether it's positive or negative, is always positive. So sometimes we are interested in distance. A number is from origin 0 of the real number line without regard to direction. So the symbol we use is the bar between the A. So absolute number of A is A. Absolute number of negative A, still A. The absolute value of 0 is 0. Always is positive. So this is a very good example. Evaluate the following. This is absolute value. The reason why we are using the symbol line to line. So absolute of negative 4, the answer will be positive 4. Absolute number of 0 is 0. Absolute number for positive 2 is 2. Absolute number for negative 5, negative, and up negative 1. So here you can see that we have negative 3, absolute number become positive 3. Then negative 5 become positive 5. Then we find the absolute of the difference of the two. Now let's see our solution here. The first one, we said negative 4 will be positive 4. And B will be positive 2, stay positive 2, so it's 2. And C, 0 is 0. And here we have to be careful. So you can see the first thing we do, I find the absolute of negative 3, and it's positive 3. Now I will combine the two, negative 5, negative 3 will give me negative 8. The absolute number of negative 8 will give me positive 8. So we look at this question, you see that we have the bar here for negative 3, we have it. So this we have to, it's like a parenthesis. We always do the inner parenthesis first. So here I have negative 3, I have to find the absolute number of negative 3, that will give me positive 3. So this bar will be gone. Then we have only one now. The one here, the one here. Then we combine these two since we have two values with an arithmetic operator between them. So we get negative 8. So absolute numbers, we said, always positive or negative is positive. So if it's A, even if A is less than 0, it's still A. So the next is some few examples. We have the operation with a real sign numbers. So let's see the first question. We have plus 5, plus or plus 6. The answer will be plus 11. because both of the values are positive and we are adding. Now here we have -6 plus negative. So here also we combine the two. So since the denominator is the same, 6, we keep our 6, then we combine -1 plus -2. That will give me -3. And we know 3 can go into 6 is 2, so we get -½ Now adding two real numbers, but one have a different sign. So here we have -4 plus 3. Which value is bigger? 4. What sign is 4? Negative. So our answer should be negative. And since it's two values, but they have a different sign, we have to subtract. So 4 minus 3 is 1. But since 4 is bigger than 3, we keep the negative sign. The next one, we have +5 plus -3. Again, the signs are different. So find the difference between the two. The answer is 2. But since 5 is bigger than 3 and 5 is positive, the answer will be +2. The same thing applies to the next example, -11/7 plus +1. -11/7 is greater than 1. So find the difference of the two. You get -4/7. The reason why it's negative, again, -11/7 is greater than 1. Now here we have negative and negative. Now, if all the signs are positive, we add it and keep the positive sign. So the same thing with negative. If all the signs are negative, add all the negative values, then we keep the sign. But sometimes we have to be careful. It doesn't go like that. You see here I have -9. Then we know in elementary mathematics, negative times negative is positive. Positive times positive is positive. The only time we get negative is when the two signs are different. So because of that, here, since I have negative, here negative, I will multiply these two to remove the parentheses. So I will get -9 plus 8. And I will get 1 now. And since, again, 9 is bigger than 8, we keep the negative sign. Let's look here, 16 minus 8. You see this one is better. We don't have negative and negative. We have positive. So positive times negative is negative. So we get 16 minus 8, which will give us +8. But again, question, the first one, we have negative and negative here. So negative times negative is positive. So that's what changed this value to positive. Here we have negative and negative. So negative times negative is what? Positive. 3 times 4 is 12. Positive times positive is positive. 3/4 times 4, the 4 will cancel the 4 here. So we get 3. Then positive times -3 will give me -15. -3 times +4 is -12. And negative divided by negative is positive. 14 divided by 2 is 7. Positive divided by positive is positive. 36 divided by 4 is 9. So we should know the order of operations. This is, again, almost like elementary maths, but this is just a review for pre-calculus. And we are going to cover more difficult materials in the future. So the order of operation in arithmetics, we always know we do the parentheses first. After parentheses, we do exponents or power. After that, we do multiplication, division. Then after that, we do addition, subtraction, from left to right. So again, this is just a review for pre-calculus, and we cover the real numbers here, and I wish everybody the best, and we meet in the next class, which will be our lecture number 3. Thank you. Bye.